Look up at the night sky. What do you see? It's like a vast, dark canvas sprinkled with tiny points of light. For thousands of years, humanity has stared into that darkness. But we saw more than just stars. We saw possibilities. We saw worlds waiting to be discovered. This cosmic ocean has always called to us. It whispered promises of adventure and knowledge. We are, at our core, an exploring species. It's written into our very being. We climbed mountains, we crossed oceans. So really, it was only a matter of time before we looked up and decided to cross the void itself. The key to unlocking the cosmos was understanding the rule book first. This is where the story of rocket science truly begins, with Isaac Newton. Why does an apple fall from a tree? Why does the moon circle the Earth without flying away? He wrote down these rules in 3 simple, elegant laws. We now call them Newton's laws of motion. Newton's first law says that an object will stay still unless a force pushes or pulls it. Think about a hockey puck gliding across the ice. It just keeps going in a straight line until it hits the wall. Newton's second law gives us the math behind movement. Force equals mass times acceleration. Newton's third law states that for every action, there is an equal and opposite reaction. The downward blast of the exhaust is the action. The majestic upward climb of the rocket is the equal and opposite reaction. The first rockets were born from fire and ingenuity in China, almost 1,000 years ago. These were the world's first rockets, known as fire arrows, a terrifying new weapon. They were unpredictable, but their psychological impact was immense. The dream needed pioneers like Konstantin Tsiolkovsky, who worked out the fundamental equations of rocketry. Then there was Robert Goddard, who built and launched the world's first liquid-fueled rocket. The flight lasted only 2.5 seconds, but it was a monumental achievement. After World War II, the world was split in two. A tense Cold War began between superpowers. Soon, a new arena for rivalry would emerge, space itself. The rocket was about to become a symbol of national pride and power. On October 4, 1957, the Soviet Union launched Sputnik 1, a small metal sphere that changed the world forever. For Americans, the news was a profound and terrifying surprise. The Soviets were flying over their heads every 96 minutes. The American response was swift. A new agency was created, NASA. The space race was now official policy. President Kennedy stood before Congress and issued a stunning challenge. He declared that America should commit to landing a man on the moon before the decade was out. The mission was given a name worthy of its mythic ambition, the Apollo program. To get to the moon, NASA needed the Saturn V, a towering symbol of human ambition, higher than the Statue of Liberty. Its 5 F-1 engines generated over 7.5 million pounds of thrust, burning 15 tons of propellant every second. On July 20, 1969, Neil Armstrong took his famous first step. Kennedy's promise was fulfilled. For over half a century, rockets were incredibly wasteful. The most expensive parts were thrown away after every flight. It was like building a brand new jumbo jet for every flight, then pushing it into the sea upon arrival. A new company arrived with a radical idea. SpaceX wanted to make rockets reusable like airplanes. The Falcon 9 was designed from the ground up with reusability in mind, featuring 9 Merlin engines for redundancy. After stage separation, the booster performs a boost-back burn, reversing course toward the landing site. Titanium grid fins deploy to steer the 14-story cylinder with remarkable precision through the atmosphere. The final moments are critical. The landing burn must rapidly decelerate from hundreds of miles per hour. In December 2015, SpaceX achieved a perfect landing. The crowd roared, proof that the crazy idea could work. The sight marked the beginning of a new era. The era of reusable rockets had truly begun. Reusability completely revolutionized the economics of space access, dramatically slashing launch costs. Suddenly affordable, companies could plan vast satellite networks like SpaceX's Starlink constellation. The high frequency of launches creates a virtuous cycle. More data, more experience, rapid improvement. Companies are developing super heavy lift rockets like Starship, designed to be fully and rapidly reusable. These colossal machines are being built for establishing permanent human settlements on the Moon and Mars. NASA's Artemis program aims to establish a sustainable human presence on the lunar surface. Looking up at the night sky, we no longer see an impassable barrier. We see a destination. Space exploration holds up a mirror reflecting our curiosity, collaborative spirit, and courage. The rocket is our answer to the cosmic call, the vessel built from reason and dreams, carrying us to our destiny as explorers of an endless frontier.